Hello everyone, myself Hena Shah, Assistant Professor at LG Institute of Engineering and Technology. Today we are going to begin a topic called Maclaurin Series. We'll solve its few examples. Then we'll see some standard Maclaurin Series and then based on it we'll solve its few examples. So first topic, let us begin with Maclaurin Series. So Maclaurin Series is given by f of x is equal to f of 0 plus x upon 1 factorial f dash of 0 plus and so on. So how it is formed? So firstly we all know the Taylor series in powers of x minus a, which is given by f of x is equal to f of a plus x minus a upon 1 factorial f dash of a plus x minus a whole square upon 2 factorial f double dash of a plus and so on. So whenever we put a is equal to 0 in the Taylor series expansion, we will get Maclaurin series. So finally our Maclaurin series is f of x is equal to f of 0 plus x upon 1 factorial f dash of 0 plus x square upon 2 factorial f double dash of 0 plus and so on. So this is our Maclaurin series. Now we'll solve few examples based on Maclaurin series. So our first example is to obtain Maclaurin series of f of x is equal to sin x. So firstly let us begin with the solution. Obviously we have to find the derivatives and here always we have to put the value of a as 0. So our f of x is equal to sin x. So f dash of x will be cos x. F double dash of x will be minus sin x. F triple dash of x will be minus cos x. Now in derivative and the function itself, we will put the value of a as 0. So f of 0 will be 0, f dash of 0 that is cos 0 that will be equal to 1. Similarly f double dash of 0 will be 0 and f triple dash of 0 will be minus 1 and so on. So now let us find the Maclaurin series. So Maclaurin series is given by f of x is equal to f of 0 plus x upon 1 factorial f dash of 0 plus x square upon 2 factorial f double dash of 0 plus and so on. So finally putting the values of f of 0, f dash 0 and so on, we will get sin x is equal to x upon 1 factorial plus x square upon 2 factorial into 0 plus x cube upon 3 factorial into minus 1 plus and so on. So our final Maclaurin series of sin x will be equal to x upon 1 factorial minus x cube upon 3 factorial plus and so on. We will have odd powers of x. Now next, let's begin with our one more example, that is we have to obtain the Maclaurin series of f of x is equal to cos hx. Now what is cos hx? Cos hx is equal to e raised to x plus e raised to minus x upon 2. So firstly in this we will find Maclaurin series of e raised to x, then Maclaurin series of e raised to minus x, add the 2 and divide by 2. So let us begin to find the Maclaurin series of e raised to x. So f of x is equal to e raised to x. So our f dash of x, f double dash of x, f triple dash of x, etc. all will be also e raised to x. So in every function and derivatives, what we will do, we will put x as 0 because we have to find Maclaurin series. So f of 0 is 1, f dash 0 is 1, f double dash 0 is 1 and etc. Every derivative will be equal to 1. Now let us find the Maclaurin series of e raised to x. So Maclaurin series is given by again f of x is equal to f of 0 plus x upon 1 factorial f dash of 0 plus and so on. Now here every derivative and f of 0 is equal to 1 at x is equal to 0. So finally our Maclaurin series of e raised to x will be equal to 1 plus x upon 1 factorial into 1 plus x square upon 2 factorial into 1 plus and so on. So finally our Maclaurin series of e raised to x is equal to 1 plus x upon 1 factorial plus x square upon 2 factorial plus and so on. We'll name this as equation 1. Now we have to find the Maclaurin series of e raised to minus x. So what we will do, just replace x by minus x in equation 1. So we will get finally our Maclaurin series of e raised to minus x, that is equal to 1 minus x upon 1 factorial plus x square upon 2 factorial minus x cube upon 3 factorial plus and so on. Now to find the Maclaurin series of cos hx. First our task is to add the Maclaurin series of e raised to x and e raised to minus x. So we'll add equation 1 and 2. So e raised to x plus e raised to minus x will be equal to, we'll add both the Maclaurin series. So finally what we will get, that e raised to x plus e raised to minus x is equal to 2 into 1 plus x square upon 2 factorial plus x raised to 4 upon 4 factorial plus and so on. Now lastly we will divide this by 2. So finally we will get cos hx is equal to 1 plus x square upon 2 factorial plus x raised to 4 upon 4 factorial and so on. Obviously Maclaurin series of cos hx can be found out using derivatives also. So you can also find the derivative of cos hx 2 or 3 times and find the Maclaurin series using our formula, that is f of x is equal to f of 0 plus x upon 1 factorial f dash of 0 plus and so on. Now we will have a look at some standard Maclaurin series which can be found out using our formula of Maclaurin series. So the first series is of sin x that we have studied just. Next is of cos x. Next e raised to x, e raised to minus x, cos hx, sin hx, tan x, 1 upon 1 plus x, 1 upon 1 minus x, and last and most important, that is binomial series, which is given by 1 plus x whole raised to n, that is equal to 1 plus nx plus n into n minus 1 upon 2 factorial x square plus and so on. All these series can be found out using our Maclaurin series formula, that is f of x is equal to f of 0 plus x upon 1 factorial f dash of 0 plus and so on. Just you have to find the derivatives of the function, put value of x as 0 and you will get our required series. Now let us see the formation of graphs using Maclaurin series. So first graph that is formed using Maclaurin series is of sin x, you can have a glance at it. Next is of cos x, you can have a look at it. Next graph is of e raised to x. So the graph of e raised to x is formed using our Maclaurin series. Next 1 upon 1 plus x. Next you can have a look at the formation of the graph of 1 upon 1 minus x. Next is of log 1 plus x. So all these graphs are formed using Maclaurin series. Next, let us solve few more examples based on Maclaurin series. So our example goes as, obtain Maclaurin series of log 1 plus x and using it find the series expansion of log 1 plus x upon 1 minus x and hence find the value of log 11 by 9. Log to the base e means ln, so that is natural log. Now let us begin with our solution. Firstly our function is log 1 plus x. So start finding its few derivatives. So f dash of x, that will be 1 upon 1 plus x. Now what will be f double dash of x? That will be minus 1 upon 1 plus x whole square. We all know the derivative of 1 plus x, that is minus 1 upon x square. So f double dash x is found out using that formula. Now similarly f triple dash of x, that is 2 upon 1 plus x whole cube and so on. Now what we will do is, we'll put the value of x as 0 in our f of x and its derivatives. So start putting the value of x as 0. So f of 0, that will be log 1, that will be equal to 0. Similarly your f dash of 0, that will be equal to 1, f double dash of 0, that will be equal to minus 1, f triple dash of 0 is equal to 2 and so on. Now let us find the Maclaurin series of log 1 plus x. Now we all know the Maclaurin series is given by f of 0 plus x upon 1 factorial f dash 0 plus and so on. Just put the value of f of 0, f dash 0, f double dash 0, etc. Here f of 0, that is 0, so it's 1. F dash 0, that is 1. F double dash 0 is minus 1. F triple dash 0 is 2. So our final answer of log 1 plus x, that is equal to x minus x square upon 2 plus x cube upon 3 and so on. Now what is our task? We have to find the Maclaurin series of log 1 plus x upon 1 minus x. So firstly what we will do is, we will find the Maclaurin series of log 1 minus x. So just we have to replace x by minus x. So what you will get? Log 1 minus x, that is equal to minus x square upon 2 minus x cube upon 3 and so on. Now our final task, that is to find Maclaurin series of log 1 plus x upon 1 minus x. Now log a upon log b, that is equal to log a minus log b. Just put the Maclaurin series of log 1 plus x, 1 minus x, subtract both of them and you will get our Maclaurin series of log 1 plus x upon 1 minus x, that is equal to 2x plus 2x cube upon 3 and so on. Now we have to find the value of log 11 by 9. So what will replace x? We cannot replace x as 10 because if we replace x as 10 in the denominator it will be minus sign. So we cannot replace x as 10. So what we will put? X is equal to 1 upon 10. So putting x is equal to 1 upon 10, we will get log 1 plus 1 upon 10 upon 1 minus 1 upon 10. That is equal to log 11 by 9. So that is equal to 2 into 1 upon 10 plus 2 into 1 upon 10 whole cube by 3 plus and so on. Calculating with the calculator normally or pressing just ln 11 by 9 in your scientific calculator, you will get answer as 0.2006 approximately. So this is our answer of log 11 by 9. Now let us check one more example of Maclaurin series. That is, we have to find Maclaurin series of log sec x. So in this, we will do derivative somewhat differently to make it easier. So firstly, our f of x is log sec x. Now we will find f dash of x. So f dash of x, that is equal to 1 upon sec x, and using chain rule, derivative of sec x, that is equal to sec x into tan x. So finally our f dash of x is equal to tan x. And simultaneously we will put the value of x. So firstly our f of 0, that is log sec 0, that is 0. Next f dash of 0 will be 0. So we are done with f of x and f dash of x. Now we will find f double dash of x. So f double dash of x, derivative of tan x will be sec square x. Now in order to make our derivative simpler, we will convert this into our f of x and f dash of x terms. So sec x, sec square x, that is equal to 1 plus tan square x. So now we know what is our tan x. Tan x is f dash of x. So we will replace it. So finally our second derivative is equal to 1 plus f dash of x whole square. And here by putting x is equal to 0, we will get f double dash 0, that is equal to 1 plus f dash of 0 whole square. But our f dash of 0 is 0. So finally our f double dash of 0 is equal to 1. So remember, we will replace f of x, f dash of x in our derivatives simultaneously. Now let us find our third derivative. So our third derivative will be, derivative of 1 will be 0. Now f dash of x whole square. So derivative of that will be 2 into f dash of x, and using chain rule, derivative of f dash of x will be f double dash of x. Now in this we will put the value of x as 0. So finally our third derivative will be equal to also 0, because f dash of 0 is 0 and f double dash of 0 is 1. So finally our third derivative is equal to 0. So now let us find our fourth derivative of f of x. So the fourth derivative of x we will find using the third derivative, and we will apply multiplication rule of derivatives, that is u into v rule. So now let us find out the fourth derivative. So f4 of x, that is we will keep 2 outside, that will be equal to f double dash of x whole square plus f dash of x into f triple dash of x. Now we will put the values of f dash of x, f double dash of x and f triple dash of x at 0. So putting all these values, we will get our fourth derivative at x is equal to 0, that will be equal to 2. Now next let's move on to our fifth derivative. So you can have a look at the fifth derivative, and the fifth derivative at x is equal to 0 is equal to 0. You have to repeat the same procedure again and again to find the derivatives. Next, we will find the sixth derivative also using the same process and so on. So finally, let us now find the Maclaurin series. So f of x is given by f of 0 plus x upon 1 factorial, f dash of 0 plus x square upon 2 factorial, f double dash of 0 plus and so on. So now let us start putting the value of f of 0, f dash of 0, f double dash 0 and so on. So finally, our Maclaurin series of log sec x will be equal to x square upon 2 plus x is to 4 upon 12 plus x is to 6 upon 45 and so on. So today we have studied Maclaurin series in powers of x, that is we have to always put a is equal to 0, and next we have studied some standard series. Based on it we have solved few examples, and this is done for today. Thank you for watching.